Determine if the following telescoping series is convergent or divergent. We have the sum from n equals 1 to infinity of 4 divided by the product of n and the quantity n plus 2. To begin, this formula does not look like it would be a telescoping series, and that's because we first have to perform partial fraction decomposition. Let's begin with this. Because we have two linear factors in the denominator, we set this up as 4 divided by the product of n and the quantity n plus 2 equals a divided by n plus b divided by the quantity n plus 2. Next, we multiply both sides of the equation by the least common denominator of n times the quantity n plus 2. Notice on the left, n times the quantity n plus 2 divided by itself simplifies to 1, leaving us with 4. Multiplying on the right for the first product, n divided by n simplifies to 1, leaving us with a times the quantity n plus 2. For the second product, n plus 2 divided by itself simplifies to 1, leaving us with plus bn. And now we select convenient values of n to determine the values of a and b. For example, notice when n is 0, b times n would be 0, giving us the simple equation 4 equals 2a, and therefore a equals 2. And now we'll select n equals negative 2, because negative 2 plus 2 is 0. When n is negative 2, we have the equation 4 equals negative 2b, indicating b equals negative 2. Now we know 4 divided by the product of n and n plus 2 is equal to 2 divided by n plus negative 2 divided by the quantity n plus 2, or just minus 2 divided by the quantity n plus 2. Now we'll write the formula for the telescoping series in this form. Remember, a telescoping series is a series in which most of the terms simplify out in the partial sums, leaving only some of the first terms and some of the last terms. So now we want to determine a formula for the partial sum s sub n. Once we determine this formula, we'll determine the limit as n approaches infinity of the partial sum. If the limit exists, then the telescoping series converges, and it converges to the value of the limit. If the limit doesn't exist, then the telescoping series diverges. Let's work on this on the next slide. Because we want the partial sum formula in terms of n, for the partial sum, we'll replace the variable n with I and let n be the upper bound or upper limit of the index. Notice the formula is a sub I instead of a sub n, and the index is from I equals 1 to n. And now we need to expand the partial sum. When I equals 1, we have 2 minus 2/3, plus when I is 2, we have 1 minus 2/4 or 1/2, plus when I is 3, we have 2/3 minus 2/5, plus when I is 4, we have 2/4 or 1/2 minus 2/6 or 1/3. Notice the last value of I is n, and therefore when I is n minus 1, we have plus 2 divided by the quantity n minus 1 minus 2 divided by the quantity n minus 1 plus 2, which simplifies to n plus 1. And again, the last value of I is n, which gives us plus 2 divided by n minus 2 divided by the quantity n plus 2. And now we need to determine which terms simplify out. The first part is pretty straightforward. We see several opposites. Notice we have negative 2/3 plus 2/3, which is 0, as well as negative 1/2 plus 1/2. And now we need to see which other terms simplify out. The negative 2/5 will simplify out. Notice negative 2/5 simplifies out when we add a positive 2/5, which occurs when I is 5. So that simplifies out. And negative 1/3 is equal to negative 2/6, which will simplify out when I equals 6. So negative 1/3 also simplifies out. And now let's take a look at the last two set of parentheses. Let's first consider minus 2 divided by the quantity n plus 2. This will only simplify out when we have a positive 2 divided by n plus 1, which we won't get because notice the maximum value of I is n, not n plus 1, so we'll never get a positive 2 divided by n plus 1 from 2 divided by I. So minus 2 divided by n plus 2 will not simplify out, neither will minus 2 divided by the quantity n plus 2. However, positive 2 divided by n minus 1 will simplify out with a negative 2 divided by n minus 1, which occurs when I is equal to n minus 3. Looking at the second fraction of the formula, notice when we have n minus 3 plus 2, we do get an n minus 1, and therefore minus 2 divided by n minus 1. So the 2 divided by n minus 1 simplifies out, and so does the 2 divided by n. This simplifies out with a negative 2 divided by n, which occurs when I is equal to n minus 2. Notice n minus 2 plus 2 does simplify to n, giving us minus 2 divided by n, which again will simplify out with the plus 2 divided by n. So we have 4 terms remaining. We now have a formula for the partial sum S sub n. S sub n is equal to 2 plus 1 minus 2 divided by the quantity n plus 1 minus 2 divided by the quantity n plus 2. And now we need to determine the limit as n approaches infinity of S sub n. Notice as n approaches infinity, both fractions approach 0, and therefore the limit is equal to 2 plus 1, which equals 3. So because the limit exists, we now know the infinite series converges, and in this situation, we also know the infinite series converges to 3. I hope you found this helpful.